Implicit differentiation. We're going to learn differentiation of implicit function. What is implicit function and what is explicit function? Have you heard of it before? Anyone? No. So whatever functions we differentiated until now is explicit function, where y is explicitly written in terms of x, like sin x, cos x, tan x, e to the power x. These are explicit function. What is implicit function? Where you cannot make y a subject. You cannot write y in terms of x. Those functions are implicit function. For example, if I write xy equals to sine y squared plus 2x. If I write like that, and we make y as a function, y as a subject. Are we able to make y as a subject? Not possible. No. So this is called implicit function, where you cannot write y in terms of x. Okay, so this is an example of implicit. So we're gonna learn how to differentiate these kind of functions, right? Before we do this question, we'll do a simple differentiation. So let's say we want to differentiate let's learn how to differentiate y squared. For example, u is equal to y squared. Okay, u is a function of y, which is y squared. We want to find out du over dx. All right, we want to find out du over dx. I want your attention here. So to differentiate u in terms of x, but u is not a function of x. We can't differentiate. We can't say to y, right? Wait, we cannot say to y because we are differentiating in terms of x, but u is a function of y. So what we're gonna do to deal with this problem? We're gonna write like this. And we write du over dx times dy over dy. dy means dy over dy is 1, right? And we write like this. Then we write like this way. So du over interchange. So du over dy times dy over dx. So du over dx gonna be du over dy times dy over dx. Is that clear? Clear? Not clear? Ask me to explain again. So now it's easy to differentiate. See, u is equal to y squared. We will be able to differentiate u in terms of y, right? It's easy. So now du over dx gonna be du over dy, which will be 2y times dy over dx. So that's the differentiation of y squared. Differentiation of y squared is 2y times dy over dx. Am I making sense? Everyone? Similarly, if it is y is equal to u to the power 3, what will be the differentiation of u? What will be du over dx equal to?
So du over dy.
Yeah, tell me the final answer. Final.
So
Final.
3y
3 y squared
times dy.
dy over dx. Just differentiate this and just write dy over dx. This is the method. I have explained it in the method. What we do. So we got du over dx equal to du over dy times dy over dx. Du over dy is differentiation of y squared. It's 2y. Right? Any problem? Y cube. See, it's easy to differentiate in terms of y, right? Du over dy is going to be 2y. Similarly, du over dy is going to be 3u square, 3y square, 3y square times dy over dx. Am I making sense? Just remember this. If it is given in terms of y, just write differentiate as you differentiate x. The way if you differentiate x, you differentiate the same way. Extra you need to write dy over dx. That's it. Is that clear?
How's the number two related? That's two Y.
2y dy over dx. So as it was y squared, it's going to be 2y. Yeah, if it is 3 y to the power 3, it's going to be 3y squared dy over dx. Is that clear? So that's how we differentiate y. Okay. Let's do a easy differentiation first. There's a differentiation. Y equals to sine xy. I want your attention here. We're going to differentiate this. This is a implicit function because we cannot write y in terms of x. That's where I'm going to differentiate, and I want everyone's attention. So to find dy over dx in this case, we're going to differentiate the left hand side and we're going to differentiate the right hand side. Because these two functions are equal, the differentiation will be also equal. So what's the differentiation of y? Dy over dx. Differentiation of sine is cos. Okay, so cos xy. Clear. Now we're going to differentiate this thing, right, using chain rule. So focus over here. So differentiation of what rule we're going to use it here? As it's a product of two functions xy, we're going to use product rule. So x times dy over dx plus y times dx over dx is differentiation of x, right? Am I making sense or not? So what will it get? Dy over dx equal to cos xy x dy over dx plus y, right? Any problem in this step? Any 100% clear? So, not clear. Ask clear. Which one not clear? This step is clear? So, not clear. Okay. So, we are differentiating y. We're going to do dy over dx. Differentiation of sine is cos xy. And we have to differentiate xy. So, this is the product. Then use product rule. U v dash plus v u dash. Differentiation of x is 1, right? So dx over dx is 1. Am I making sense? There, it's not over here. We need to make dy over dx as a subject because that's our answer is gonna be, because we want to find dy over dx, right? So let's simplify it. Let's simplify this. So we're going to write dy over dx equal to x cos xy dy over dx plus y cos xy. Am I making sense? I've just multiplied cos xy to this, cos xy to this. Yeah. Cos xy gets multiplied with x cos xy times dy over dx plus y cos xy. All right. We want to find dy over dx, right? So here is a dy over dx, here is a dy over dx. We will bring to one side. So dy over dx, you bring it to the left, it becomes negative. So become negative. Sure. So 1 minus x cos xy. Clear? That is equal to y cos xy. I've taken common. To the left, take common. So dy by dx common from here, so gonna be 1 minus x cos xy equal to y cos xy. Is that clear? Now we want to dy by dx, so this whole thing will go in denominator. So dy by dx equal to y cos xy over 1 minus x cos. That's answer. So is there anyone who has done G?
I'm doing G.
G. Okay.
I'm still looking.
So if x cubed, we can write this whole function as u, x cubed minus 7xy plus y cubed. What we want to find is du over dx. Keep on differentiating. The differentiation of x cubed gonna be 3x squared minus 7 differentiation of xy using product rule. So x dy over dx plus y times 1 plus differentiation of y cubed is 3y squared. That's answer. Is this clear? We're going to differentiate. Here is normal differentiation. X cubed is 3x squared minus 7 common differentiation of xy. So product rule. X dy over dx plus y times 1. Product rule. Differentiation of y cubed is 3y squared dy over dx. Clear? H u is equal to x sine y plus y cos x. You want to find du over dx? Because it's a question says differentiate with respect to x. So you're finding du over dx. All right. You tell me, I will write on the board. You will say. Chime in and talk. Yeah, tell me. So we got what we will use here. What are tools? Tell me what will be the differentiation of x and y? X differentiation of sine, yeah, say
Cos.
okay. So cos, okay,
Y
y,
plus,
this is not there. Because we are differentiating y, we need to write dy over dx. Right? Then sine y times 1. That's a differentiation of this. Yes. Now we're going to differentiate this one. Boom. Then how will we differentiate y cos x? Y times
negative sign.
negative sine. Okay, then that's ub dash, then plus du dash, right? Tell me, plus cos x, that's v. Nice. Differentiation of y is dy over dx.
Okay,
That's
so I don't understand why is there like dy over dx? But what's
where here.
yeah in both of them like what's
So
What's
we are differentiating this whole thing,
sure
whole function, which is we are assuming this u.
okay sure
We are differentiating in terms of x.
Yeah.
du over dx, gonna be, this is then x squared
Okay.
minus 7. So here is a product of two function, x, y. We're gonna use product rule, right? So x, which is like u v dash, v dash means product, differentiation of y is dy over dx. What's the differentiation of y in terms of x? dy over dx. Plus v u dash. So y u dash is like 1, x differentiation of x is 1,
Yeah, the S already.
yeah? Clear?
Okay.
Now, differentiation of y cube, it's like 3y squared. We are differentiating in terms of x. I'm just explaining to you, right? You need to get the y cube. And we want to find du over dx, it's gonna be du over dy times dy over dx. du over dy, it's gonna be 3y squared.
Times, okay, this one's.
So whenever you're differentiating y in terms of x, you differentiate the way you differentiate x. But extra, you're gonna write dy over dx. That's the reason why do you write dy over dx. Clear? Yeah, which one? Which? Product rule? Product rule? So x, differentiation of sine y is cos y. And extra we're gonna write dy over dx. Because we are differentiating in terms of it. Is this part clear to you? Why are we writing dy over dx extra? Why? Because we are differentiating in terms of x and u is a function of y. So extra dy over dx is coming. Because we are differentiating in terms of x, function is given in terms of u. Similarly, when you are differentiating sine y, is gonna be cos y times dy over dx. Extra dy over dx will come, right? So this cos y dy over dx is actually the differentiation of sine y. There, then sine y times differentiation of x is 1. Product rule. Again, we are applying product rule. So y times differentiation of cos is a negative sign plus cos x times differentiation of y is dy over dx. So we have to find out the gradient of the curve at 0, 4. This is the function or equation of the curve given to us. So to find out the gradient, we need to find out dy over dx, right? And as it is an implicit function, we have to use implicit differentiation. So we will keep on differentiating the left hand side and right hand side until we differentiate x. So we're going to use chain rule as well. All right, implicit and chain rule. So differentiation of left hand side. 5 e to the power x y squared. So it's a product of two functions. We need to use product rule as well. Right? So 5 as it is. E to the power x. Differentiation of y squared. Boom. That's it. Times dy over dx, right? Plus and so plus y square ub. So b u dash So differentiation of e to the power x is e to the power x. Is that clear? So that's the differentiation of e to the power x y square. Now we're gonna do differentiation of 2 e to the power x y. So go. Tell me the next step. It's 2
Okay, so it's e to the power x times dy over dx.
and dy over dx. Next to t how? Plus
Y
y
to power e to the power x.
okay. Equal to
0.
here. Because we are differentiating both side constant differentiation is 0. So now you have dy over dx here, dy over dx here. Let's do the simplification. Bring it to the left hand, keep it to the left hand side and bring everything to the right hand side, the other things. Right? And get dy over dx from there. Once you have dy over dx, you can substitute the point given 0, 4. And then you will get dy over dx. See, until you learned implicit, before that, whenever the point was given to you, you only used to substitute x coordinate. You only used to substitute x coordinate. But here, because dy over dx will be a function of x and y both, you will substitute both x and y coordinate there. Am I making sense? So, get dy over dx. Get dy over dx expression and substitute the 0, 4 there. Parametric differentiation. What is parametric form? What is the parametric? We have done this in lectures.
They have article pay, it's in line numbers.
So it does not have IJK, that's with respect to vectors, but what is parametric form? Like x. So how does the parametric form look like? Tell me the parametric form of vector equation of. Yeah, the vector equation of line. What is the parametric equation of line? Remember the parametric equation of line? X equal to 1 plus 2 lambda, y is equal to minus 1 plus 3 lambda, z is equal to 2 plus 5 lambda, like that. So x, y, z was written in terms of another parameter lambda. Right? X, y, z written in another parameter lambda, that's called parametric form. A curve, equation of curve can be written in terms of another parameter. Like line, you have line 4 plus 3 lambda, 5 plus 7 lambda, then that is equal to minus 1 plus 2 lambda. That's the equation of the line, parametric equation. Similarly, there can be parametric equation of curve. I'll give you one example. You know this, uh, x square plus y square is equal to 4 square. What is it? What is this equation? Algebraic form. What is that? You learned in S level. What's the equation?
The circle.
Circle. That's the equation of circle, right? X square plus y square is equal to r square. But actually, we can write the parametric form of this as x is equal to 4 cos theta, y is equal to 4 sin theta. Look at both. X is equal to 4 cos theta and y is equal to 4 sin theta is the parametric form of circle. And I'll show you why this represents this. So x equal to 4 cos theta, y is equal to 4 sin theta. This is the parametric equation of circle. And let's prove it. So we're gonna do square and add. Square and add. So if you square and add these two equations, the result will become x square plus y square equal to 4 square cos square theta plus 4 square sin square theta. X square plus y square equal to 4 square common cos square theta plus sin square theta, which is equal to
One.
1. X square plus y square is equal to 4 square is 16. So this is algebraic equation of circle. This is parametric equation of circle. So curve can be equation of the curve. Either it can be like this algebraic form, or its x and y is written in terms of another parameter theta. Here the another parameter is theta, so that's why it is called parametric equation of circle. Parametric version of circle. Am I making sense? Parametric equation or parametric form is clear. So different curves can have normal equation in terms of x, y, or it can have parametric form as well. Now we're gonna learn if parametric form is given, how do we differentiate the parametrics? Clear? Let's do this. Let's take this example. So x is given in terms of 4 cos, x is given in terms of theta, 4 cos theta, y is here is 4 sin theta. Okay? What we need to find is dy over dx. X is given in terms of theta, y is given in terms of theta. We want to find dy over dx. So what we gonna do? Simple. See, x is given in terms of theta. From here, we can find out dx over d theta. What is dx over d theta? Tell me.
4 minus 4 sine
Minus 4 sin theta.
times. Yeah, that's it.
Am I making sense? See, we are differentiating in terms of theta. So it's simple. Negative 4 sin theta. Clear? We can find out, similarly, we can find out dy over d theta, which is equal to tangent net half. To get the board. 4 cos theta. So we got dx over d theta, dy over d theta. We want dy over dx. So isn't it simple math? If you divide this by this, isn't it dy over d theta divided by dx over d theta? Right? Divide d theta gets cancelled. You get dy over dx. So dy over dx is gonna be 4 cos theta over negative 4 sin theta. 4 gets cancelled, negative 4 odd theta. That's is that clear? 100%. So whenever parametric form is given to you, dy over dx gonna be differentiation of u. If it is y is given you have a V form. So it's gonna be U dash over V dash, like differentiate in terms of theta, differentiate V in terms of theta, divide.
Or can you say that again? What you
Uh,
just said?
Okay, so X is given in terms of theta, Y is given in terms of theta.
Yeah.
And we want dy over dx, so it's gonna be, y, let's say y is u over v. Right? X and y is given in terms of theta
Sure.
or in terms of t, another parameter. Dy over dx gonna be, dy over dx gonna be differentiation of y over differentiation of x. Like that's what we have done here. We differentiated y in terms of theta, differentiated x in terms of theta, divided.
When you say parameter, you mean like a variable, right?
Variable like, so
Theta or t or.
theta, so x is given in terms of theta,
Yeah.
y is given in terms of theta. We want dy over dx.
Yeah.
So we can directly find dy over dx as differentiate y in terms of theta, x in terms of theta divided. For example, other example can be is x is equal to t square minus 3t, y is equal to 4 3 5 minus 7. What is dy over dx? Tell me.
Y. Let me just give me a second. Let me-
How much? 4? What do you think? So differentiate y, differentiate x, divide it.
20t over to the power of 4
20t to the power of 4
divided by
divided by,
2t minus 3.
correct. Question 11. X is 3 plus 3 sine square t. And y is 2 cos cube t. You have to find dy over dx. So first find out dx over dt. Differentiation of 3 is 0. Differentiation of 3 sine square t. So 3 times sine squared. So first we differentiate the power. This will become 2 sine t. Right? And the differentiation of sine is cos. So you're gonna get 6 sine t cos t. Is this making sense? Dx over dt. Clear? We want to find out dy over dt. Because dy over dx is dy over dt divided by dx over dt. So we're gonna differentiate y, just given in terms of t. So this is gonna be 2 times 3 cos square t times negative sine t. Am I making sense, everyone? Is this part clear? So first we differentiate the power. So this is 2 times 3 cos square t, differentiation of cos is negative sine. So this you get negative 6 sine t cos square t. You want to find out dy over dx, so we need to differentiate dy over dx gonna be dy over dt divided by dx over dt. So we're gonna divide it, right? Let's divide it. So minus 6 sine t cos square t over 6 sine t cos t. Is it clear? Cancel what you can cancel. What you can cancel? Sine t gets cancelled. Cos t also gets cancelled. So finally you should be getting negative cos t, right? So dy over dx is negative cos t. Am I making sense? Here. So that's it. That's it. Can you try 12? 12 quickly, then we will take a break of 10 minutes. Try number 12. So first we differentiate, which one you do? This one. This one. So first we differentiate the power. Right? So it becomes 3 cos pi t. Then we differentiate cos, which is negative sign. Chain rule. Try 12. Easy question. So what kind of differentiation you need to do in this number 12? What kind of? What kind of form? Number 12. Implicit. So do implicit differentiation. Question 12. Ln xy minus y cube equal to 1. So simply we need to prove the dy over dx, right? So just differentiate. So differentiation of ln is 1 over x. Ln x is 1 over x. Or ln of function is 1 over function, and then we will differentiate the function. This one, this rule. Ln fx is 1 over fx times f dash x. Right?
Yes.
Okay? And just remember what ln x is 1 over x and chain rule. You can take it that way as well. So it will be 1 over xy times differentiation of xy. Differentiation of xy minus y cube is 3y squared dy over dx y dash. Differentiation of 1 is 0. Okay? So 1 over xy times xy dash is like, it's like x y dash plus y times 1 minus 3y square y dash equal to 0. Clear? Now simplify. So this is gonna become xy dash over xy plus y over xy minus 3y square y dash equal to 0. So x gets cancelled. So y dash common 1 over y minus 3y square equal to negative y over xy. Y also gets cancelled. Y dash equal to negative y over x 1 minus 3y. Is that the answer? Yeah, it is the answer. So y over x ty cube minus 1. That's what we have to prove. Simplification. It's a simplification. Once you are done with differentiation, it's just after that it's simplification. Okay. Yeah. These are the rules. It's given in the booklet. Given in the booklet. No need. It's given in the booklet. Check the booklet, you will find it. The next part of the question, it says the tangent is parallel to the y-axis, means gradient has to be infinity, right? Yeah, which means dy over dx has to be infinity, or dx over dy has to be 0. If something is infinity. So you have dy over dx. You can get dx over dy, just take the reciprocal and equate it to 0. Am I making sense? Take the reciprocal of dy over dx, you get dx over dy, equate it to 0. And you'll get it. Okay? So you can do that at home. We're going to take a break of 10 minutes. So 10:25 right now, 10:24 actually, and we're going to meet at 10:35. All right? We're going to start integration. We are done with differentiation.